Hi everybody. Let's practice. Let's practice with the law of sines and cosines. And these are the kind of questions you might expect on a quiz about the law of sines and cosines that you could take next week. Or it could be this week, depends on when you watch this video. I hope that you've already given these questions a serious effort before you watch this video. Then check them over and submit it at Canvas. So let's call this assignment number 50. Triangle XYZ, you've got angle X being 75 degrees, angle Y being 60 degrees, and side little x, opposite angle x, we'll find side little x is 20 centimeters. Show the process as you find the lengths of the other two sides. Ask me to find side little y first. That would be opposite angle y, with that 60 degree angle right there. And here's how the law of sines would look. This is the process I should show. The sine of 75 is to the length of its opposing segment, 20, as the sine of 60 is to the length of its opposing segment, y. You look at that for a second and tell me how I'm going to solve that proportion. How am I going to get y out of that? And it appears to me that, let me write that out, I guess, 20 sine 60 divided by the sine of 75. We get that, we'll know why. Turn on the calculator, clear all the junk you got, check on that mode. I'm in degree mode and I'm glad I am. Here I go. 20 sine 60 divided by the sine of 75. Check that carefully, and it looks good to me. Enter that, I come up with 17.9. That's an answer out of box. That's this length right there, 17.9. Let's go for angle Z right now. I mean, the side that's opposite angle Z. I see that these two angles add up to 135. That would leave 45 degrees right here. Knowing that angle, I can find the opposite length if I use the law of sines. Here's side little z, opposite angle z. I go with the given that the sine of 75 is to the length of the opposing segment, 20. Is the sine of 45 is to the length of its opposing side, little z. There's the proportion I got to show. And then what would z equal? You don't have to write this to make me happy. I know it's going to be 20 times the sine of 45 over the sine of 75, and maybe that's really obvious to you, but if it is helpful, then take the time to write that out. But you would calculate it for me. 20 sine 45, 45 divided by the sine of 75. Now coming up with that being 14.6. These are all centimeters, aren't they? Yeah, because that was centimeters, this would have been centimeters, and that would have been centimeters as well. I'm not going to fret about the units, but we ought to be cognizant of them. 14.6 right there. That's the shortest of those three segments, and it is opposite of the smallest angle. Opposite a bigger angle, a bigger side, and the biggest angle, the biggest side. That all makes sense to me. Park rangers, Frank and Ernest. Here's Frank, I guess, and here's Ernest. They both sight to a bear's den in the distance over here. The angle for each line of sight is shown. And we're measuring this angle to the bear's den across the line, the line from Frank to Ernest. A 75 degree angle and a 60 degree angle. Show the process as you find the distance from both Frank and Ernest to that den. I want to know the distance from Frank to the den, and that would be opposite angle E. I'd call it side little e for the moment. And this side would be side little f, opposite angle f. I'm going to need to know this angle. And yeah, these angles do add up to 135, don't they? So this was another 45. I didn't mean for that to happen. That was kind of shoddy workmanship that we got the same angles that we got in the last triangle. Well, we got different numbers coming though. But wouldn't expect those to be the same. Hit it with the law of sines. The sine of 45 is to the length of its opposing segment 300 as the sine of, well, who you want to go for? Want to go for E? I will. Then I'll have to use the opposing angle. As the sine of 60 is the segment little e, opposite angle E. E will equal 300 sine 60 over the sine of 45. Let's dig E out of that, report it right there. 300 sine 60 divided by the sine of 45. Check that. I think it's all good. So I'll say that's 367.4. Those would have been yards. Let me put that on my sketch just to compare things later. 367.4. Now, opposite this larger angle, I would expect this to be larger than that, probably bigger than 400, but let's see about that. How far is Ernest from that bear's den? We call that segment F. And I'll go back to the sine of 45 is to the length of the opposing segment 300 as the sine of 75 is to F. F will equal 300 sine 75 over the sine of 45. Evaluate that with me. 300 sine 75 divided by the sine of 45, huh? Check that through, looks carefully done. I'm going to hit enter and declare that length to be, over 400, 409.8 feet from the yards from the bear's den. Okay, so we know about Ernest and Frank and how they're running out. Oh, that should have been a lowercase f. And that was the lowercase f was how far Ernest was from the den. Here's another one. This stuff I'm thinking of around the house here. The road from Abel's house to Charlie's house is 500 yards long. Here's Abel's house and here's Charlie's house, and this is the road, I guess, 500 yards long. Zach, on his four-wheeler, left Abel's house at an angle with the road of 58 degrees. He took off on this path with a 58-degree angle with the road. After going 300 yards, and I guess this must have been those 300 yards right there then. Zach breaks down on that four-wheeler. There he is out in the muck. And he needs to make it to Charlie's house. I guess I'll have to find me a ruler. I'll figure this distance. That's the distance to Charlie's house. And we like to find that distance. I could call it little a. We could call it ZC, and I wouldn't be offended either way. But what we ought to be catching is we got a side and an angle and a side given to us. And that should clue us to use the law of cosines. And in class, I'd stop this and say, man, what did you get for the law of cosines there? And stress everybody about how to set that up. That's what I ought to do. You think about that ahead of time. A squared will equal, and when you work off of this angle to find that opposite side in this side angle side relationship, you will work with the adjacent lengths. 300 squared plus 500 squared minus 2 times 300 times 500 times the cosine of the included angle, 58 degrees. Yeah, buddy, that's the law of cosines right there. We can get a squared out of that, which is not terribly interesting. What I really care about is just a itself. Let's hit all those buttons and see what we get. 300 squared plus 500 squared minus 2 times 300 times 500 cosine 58. Check all that out. Looks pretty carefully done. 300, yeah. That's the square of that answer, which is not really interesting to me. I'll scribble it for a minute though. 181,024 and change, 0.2 is it? Take the square root of that amount though. And how about he's 425 yards from Charlie's house? 425.5. Because we did have that 0.46, so I'll say 425.5 yards. He'll have to drag his four-wheeler to get to Charlie's house. Charlie's a pretty good mechanic, we're thinking. Let's play some more. Clear all the stuff out of the way here. I don't want to confuse myself with other things. There we go. Here's a cell tower, best I can sketch that. Able sites to that cell tower in the distance with an angle of elevation of 8 degrees. And Beth, who's 400 feet closer, let this distance be 400 feet. Sites to the top of that same cell tower, they both got protractors with them, being students of geometry, don't you know? 14-degree angle. And we are to use the law of sines to find segment BD. You might be saying, hey, we can use the tangent twice and set them equal to each other and figure that. No, I don't want to do it. That's a lot more complicated than I want to put on a test. Let's go for segment BD. I'm going to call it Z for the moment and find that length that we're labeling as Z. That's really segment BD, and I can hit that with the law of sines, but I would need to know an angle there. And there's a couple clever ways you can find that angle. If this was a 14, then this one would have been 166. That way they add up to 180. And these two would add up to 174. Subtract that out of 180. This angle is just going to be 6 degrees right there, huh? But you might have been thinking all along, I don't need to do all that. I know that this exterior angle on a triangle should equal the sum of the remote interiors, so 14 had to equal 8 plus 6. One way or another, we had to come up with that being a 6-degree angle right there. Now we can get this length that's labeled as BD, but I'll call it Z. The sine, we could use the law of sines too. The sine of 6 degrees is to the length of its opposing segment 400, as the sine of 8 degrees is to the length of its opposing segment, which I've labeled as Z, just in interest of brevity. Solve that for Z. It would be 400 sine 8 divided by the sine of 6. That'll give me Z. Hit that with my calculator. You will too. Wow, did you hear that graph? That's something special, ain't it? That's not what we want to talk about though right now. Let's do this. 400 sine 8 divided by the sine of 6. That's all correctly written. That tells me 532.6. What are we talking about there? Feet? Yeah, that's what this thing would have been. That's like maybe that's a guy wire, maybe that's just the hypotenuse of a right triangle, but it's 532.6. What I try to scribble right there. And show the processes you find how tall the cell tower is. Let me do that. I'm going to use right triangle trigonometry. But actually, no, let me just stick with the law of sines, although this is a right triangle. Let me show you a little something here. The sine of 14 is to t, the height of that tower, as the sine of 90 is to its opposite length, which is that hypotenuse, 532.6. And a very interesting thing is, what's the sine of 90? And I'm here to tell you that the sine of 90 is equal to 1. Check me out. Sine of 90 is 1. So that's just 1 right there, and 1 times t is just going to be t. So it makes me think that this would be 532.6 times the sine of 14 degrees. That should be the height of that tower. Because the sine of 90 is just 1. 1 times t is just equal to that product right there. I'm going to find that product. I don't even really have to type out the, get that decimal number. I'm just going to say 532.6 times whatever the sine of 14 is. The calculator will replace that with me. And that tells me 128.8, I figure. Yep, 128.8. That would be the height of that tower. I guess if this were all measured in feet, then that would be 128.8 feet. Could you have used the straight sine? Yeah, you could have, and it would have worked just fine. Let's take that little walk and look. The sine of 14. I know I'm looking for the opposite, and I know the hypotenuse. Working with this angle, I'm not using the law of sines this time. I'm just going to check on that with straight right triangle trigonometry, which is not necessary, but seems appropriate. Sine is opposite over hypotenuse. That hypotenuse was 532.6. What else is the sine of 14 equal to? And that's 0.2419 over 1. So what am I going to get out of that? If I go with that 0.2419 times 532.6, I'm coming up with 128.8 again, huh? Pretty much the same number I had last time. So I didn't need to do that. I'm just showing you that we could have used the law of sines, or we could have used just a straight sine function. I kind of like the law of sines every chance I get. Check this one out. There's a brand new palm tree just got planted. It's an old palm tree, but it's new to this location. And a support cable 50 feet long is attached to stabilize it. Let's make a note that that's 50 feet right there. Always label that sketch. I don't know if this is a right, I guess I could assume that's a right angle. And I guess I could use the right triangle trigonometry, but the cable is staked to the ground at a point 16 feet from the palm. Show the process as you find the angle the cable makes with the ground. Now you could, actually you could say arc cosine 16 over 50, and that would work just fine. But I think it would be kind of clever of us to try to use the law of sines. Could I? I think I could. Let's see what I might do to make that happen here. I think I'd have to go for this angle first if I was using the law of sines. I'm going to do it both ways. We'll take a look at that, and I would accept either way from you. I would have to go for this angle because I know it's opposing length. If I wanted to use the law of sines, it would be the sine of 90 is to the length of the opposing side 50 as the sine of theta is to its opposing side 16. If I work on that out, I'd be able to get the sine of theta. It would be 16 sine 90, but sine of 90 is equal to 1. I'll go ahead and write it that way anyway, 16 sine 90 over 50. So I guess the sine of this thing, I'm going to get that decimal number. 16 sine 90 divided by 50. I got that amount, 0.32. The sine of 90, excuse me, the sine of theta is equal to 0.32. Let me arc sine that amount, and I can get what theta is. That's this angle up here, though, huh? Arc sine 0.32. I come up with 18.7 degrees. But now, what would this angle have to have been then? And I know that these two angles have to add up to 90. I'm assuming this palm tree is perpendicular. So this must be 90 minus 18.7. It's kind of contrived. That's going to come up with a 71.3 degree angle. That's what I say that this angle should have been, 71.3 degrees. What if you had used straight right triangle trigonometry there? Let's take a look. Working in this right triangle, I wish I knew this angle. I know the adjacent, I know the hypotenuse. Adjacent and hypotenuse, if I'm thinking so, ka, toa. Adjacent and hypotenuse, I should be thinking cosine. I'm just going to check on that stuff and say the cosine of this angle would be adjacent over hypotenuse. The cosine of theta would be 16 over 50. So theta itself, oh, I shouldn't be saying that. That should be, let me call that alpha. I apologize. The cosine of alpha is adjacent over hypotenuse. There's theta, there's alpha. That's what I care about. Sorry about my slips. Alpha will be the arc cosine of 16/50ths. And I'm hoping that's going to be the angle we just came up with would be 71.3. Let me arc. Clear the junk. Arc cosine 16/50ths. And I'm getting 71.3, huh? Hey, that's good. That's what we got last time. That's what I wanted that thing to be. I would permit you to use the straight right triangle trigonometry there. How far up the tree is that cable attached? I guess we're looking for this distance now, aren't we? We call it h for height. And I ought to use the law of sines if I could, and I think I can nicely here. The sine of 40, excuse me, the sine of 90 is to the length of its opposing side 50 as the sine of, I'm looking for this length, I better use its opposing angle, and that was 71.3. Sine of 71.3 degrees is to its opposing length. That's the height of that bracket. I got to solve that proportion. You might remind yourself that the sine of 90 is equal to 1, and 1 times h will just be h. You could type all that in if you wanted to, but the sine of 90 is just going to be 1, so it's going to be getting this product right there. 50 times 71 point, the sine of 71.3. And I find that to be 47.4. Okay. That fit? That okay with us? We didn't know anything more about that, huh? Yeah, nothing else to compare that to, so I think it must be truthful. One more question for us to play with. It's about some guys going fishing. Let's say you and I went fishing, and we're going to agree that Galveston Island, that's my little sketch of Galveston Island. This is off its bio 61st Street going right across in here. And this is the west end, and here's our east end of Galveston Island. We leave the east end of Galveston Island at an angle with a shoreline of 65 degrees. And we go for 48 miles. And we find tremendous fishing out there. There you are, fishing, catching redfish, and mackerel, whatever you want to catch. You're catching them right there. But you got this buddy. You call your friend Robert. Robert lives over here on at San Luis Pass in a little shack right on the end of the island. He's got a nice boat. He said, man, I want to go fishing with you. He wants to go fishing with you, and he has bait, and he has a protractor. He was in your geometry class. He said, let me find a way to get out there. I want to come fish with you. You need to find the distance from San Luis Pass to your fishing spot. Let's call that distance D right there. Could have called it E, opposite angle E, but I'm calling it D for distance. And now, what do we have going for us here? A side and an angle, and a side is given. And I'm telling you, friends, when you got a side angle side, that's when you want to use the law of cosines. That distance D squared, as we set up the law of cosines. I'll shut the video down. You write out what it ought to equal. 30 squared plus 48 squared. When you look for this length, using the law of cosines, you'll use the adjacent sides. Minus 2 times 30 times 48 times the cosine, as we use the law of cosines, of 65 degrees. Let's figure that one out. 30 squared plus 48 squared minus 2 times 30 times 48 times the cosine of 65. Yeah, that's all good. Square that. Man, that's the square of the answer. That is not the answer I expected. I should take the square root of 196.9. Excuse me, 1986.9. I'll take the square root of that number right there on my calculator. Square root of that amount. Now, oh goodness, I did something wrong. I'll find it. Go to it. Square root of, let me go second answer, see if I can get that in there. Yeah, we go. How about 44.6? That's what that distance is. I'm going for it being 44.6. You tell me if I did something wrong. That would be miles, wouldn't it? That's fitting. I think that distance could have been 44.6. What angle with the shoreline would Robert make if he wants to find you? So Robert's your friend with a protractor there, and he has to know that angle right there. Let's call it alpha. How could you possibly get alpha? We do know all the sides of this triangle, don't we? We know that this was 44.6. We could use the law of sines, couldn't we? Let's do that. I need to know this angle for Robert to find the angle with the shoreline to come out here and find us fishing and catching all these marvelous fishes. So, sine of 65 is to the length of its opposing side. Good thing we figured that out. 44.6 as the sine of alpha is to its opposing line side 48. Solve that for the sine of alpha. You don't need to write that to make me happy, but I think it's not a bad exercise. 48 sine 65 over 44.6. Yeah, that'll be the sine of alpha. Let's get this a number. Get that decimal amount. Then we'll arc sine it. Sine of alpha is equal to, let me get that with you, 48 sine 65 divided by 44.6. I think that's all good. Gives me that amount. So the sine of alpha is equal to 0.9753. What must alpha be then? The arc sine of that amount. Arc sine that amount. Wow, there it is. Yeah, you could have gone arc sine with of the 0.9753. 0.9753. That would have been okay. That still would have called it 77 point. Well, one of them calls it 77.2 and the other one calls it 77.3. We'll have to accept that difference, not a problem. I'm going to call it 77.3 degrees. I would not argue with you if you called it 77.2. I think Robert gets out about that far, he'll be able to find us. And that's a nice little workout for our friends. If you've mastered these ideas, you're pretty good.